Hello everyone, welcome to my channel. I have started a personal DSA challenge where I'll be solving 5 problems per pattern, covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you're new here, you can check out the previous videos to follow along. In today's video, we'll work on maximum sum of distinct subarrays with length k. The problem states that we are given an integer array nums and an integer k. We need to find the maximum subarray sum of all the subarrays that meets the following conditions where the subarray size is k and the subarray is distinct. So the brute force approach would be, the idea would be we will generate all the subarrays of size k and we will check if all the elements are distinct. If yes, we will calculate its sum. Otherwise, we'll keep track of the maximum sum. So let's initialize a variable to track the maximum sum. And yeah, so let's make it long because the return type of this method says long, and let's initialize it with 0. So I less than equals to nums dot length minus k because we need to iterate till the last kth subarray, k sized subarray. And since we need the distinct numbers, let's take set. Let's name it set. Okay, now we need a variable to track the sum of each subarray, and also we need a boolean variable, let's say is distinct, to check if it is distinct or not. And initially let's make it true. Now in the second for loop we would be iterating from I till the size till the k, so it would be I plus k and j plus plus. Now if we need to check if the set already contains it, so if set contains the current element nums of j, then we would make is distinct false and we would break. Otherwise we will add it to the set and we will add it to the current sum. Now after this for loop we would be checking if it is distinct. Yeah, if it is distinct, then we would track the maximum sum, max of maxim and the current sum, and at the end we would return maxim. Let's run the code. Okay, it is accepted, but the time complexity would be n into k because we are checking only for the k sized elements, and the space complexity would be O of k because of this set. So this approach will give a TLE for larger inputs, so we need something better. So for that we need to think of an optimized approach wherein we can use sliding window plus hash set combination. So since we are working with since we are working with contiguous subarrays, instead of recomputing everything, we can slide the window, and the strategy would be like we would use two pointers left and right, and we will maintain a hash set to ensure the uniqueness, and we will run a window sum. If a duplicate appears, then we will shrink the window from left when the window size becomes k, and we will update the answer. So the code for that goes like this. We need set and we need window sum. Initially 0, and we also need maxim, which is also 0 initially, and we would need a left pointer. Okay, I mean the left part of the window, and we would be iterating through the right part. So in right we'll also start from 0, and it would be less than nums dot length and right plus plus. Now while set contains the index at right element, the index at right pointer, while it contains, we would remove the left pointer if it contains. So dot remove nums of length, left pointer in the sense the element at left index, and then we would remove it from the window sum. Nums of left, and we would increment left. Alright, otherwise if the set does not contain it, then we will simply add it to the set. Nums of right, and we would add it to our window sum. Now we will check if the length, we will add +1 because it is a 0 based index. If it is equals to k, then we would compute the maxim, which is math.max of maxim comma window sum, and we would remove it from the set, and we would remove it from the window sum to nums of left, and we would increment left. Okay, at the end we would return maxim. Let's run the code. Oh my god. Alright, let's submit it. Okay, it is working. Okay, let's go through one example. So here if we consider example 1, initially it will calculate the sum 154, which is 10, and then it will the current maximum sum is 10, then it will calculate the sum of this, which is 6 plus 5 11. Now the current maximum sum is 11, then it will move to the next window 4 to 9. So the maximum sum now is 9 plus 2 plus 4, which is 15. And then it will go to the next element, but the next element is a duplicate, so it will break here, and the maximum sum is 15. So that is how it works. So the time complexity is O of n, and the space complexity would be O of k because of the set. Yeah, that's it for this problem. I'll see you in the next one. Thank you for watching.